Right, let's take a look at this problem. Replace words. In English, we have conception called root, which can be followed by some other words to form another longer word. Let's call this word successor. For example, when the root n is followed by successor other, then we can form a new word another. Given a dictionary consists of many roots and sentences, and a sentence consists of words separated by spaces, replace all the successors sentence with root forming it. All the successors in a sentence with the root forming it. So that we have to concatenate them or put them in scene. So if successor can be replaced by more than one root, replace it with the root that is the strongest length. Okay. So let's say that we have car, and our root is, we have a car root and we have CA root. In that case, we replace it with car root. Okay. Here, for instance, so let's see. We go over it. Every word. Alright. What's that? What are the constraints here? Lowercase letters and space. Alright, lowercase. Dictionary length is like some that. Does not have leading trail. Okay. Then I can just split the words in, words will be equal to sentence. Let's split and print words. Return that. Let's see. Okay. So for every, so if you go to, so since we are looking for prefix, the longest prefix, we can make use of prefix tree, or yeah, we can use that, because otherwise we have to create prefix A, which will require more space. So let's create that. Okay. So let's create a try node. So initialize it. That. So the first thing we need is so every one of them has children dictionary, and then that dictionary will, by default, they'll have try node. So for this, let's import that. So do I need anything else? I don't think so. I also have to create the try, where I have to create self root, and insert function. And also find function. Right, so okay. To insert, we have to create, we need a pointer that is pointing to a root, and then for every character in string, we have to create a node and then point to it. And for that, so we have to just create the children for C, and then to use that, we can just override the current. So we just create the children, and then now we are pointing to children with current. And okay, that will be enough. And again, when we are searching, we need a current for every C in string. We have to check if C is in current. Actually, this current that's children. If that's the case, or maybe we have not. If that's the case, we just return false. Otherwise, we just current is equal to current children C. Now we return current, and that will be it. Yeah, that will be it. Maybe here we return also the last current. Something like that. Okay, so this is a basic try implementation. This will be actually true. Oops. Okay, so this will be actually true. So how can I make use of this data structure? I can simply, for every word in words, first I can just add them, or I can add the dictionary to try. For every one of them, I search it and I return the last one I have. So, okay, so for every word in dictionary, so I have to create try, try, and then so try, insert the word. Okay, I pass it and go on and insert it. By the way, I can also have like because I might not have that word. I will return that. Yeah, I should also have like end of word should be false. And at the end of this, I should just return that end of word is equal to true. Alright, so yeah, I need that. So I just insert it, and then I allow these in my try. So here, what I can do here is for every word in my words, where we get these. Okay, let me think. So just go over it. Right? So in every word, below every word, for every character in word, and then for every word I want to go over its characters, or maybe I just search if I find. So I just maybe I just find the longest. So I will do that in the find function. So I can just have like this find the word and if so this will if I cannot find it, so this will be the node I'm pointing to if node else don't else something else else we just append that to. So I'll require result okay. Join. Okay, I join them. Else result append word. Here result append. Not word, but we just append the node. Not node, but like prefix, like root. So I guess the find should return the at start it should have root string will be empty. Okay, so we will have this at the end. Okay, so we just go over it. At this point, if that's not in it, we just return the root string. Join root string. Otherwise, at the end, we just return. It's actually always the same. I can just put it here, and here I just break. Yeah. So here, just before this, root is the only append. We just append this here. Okay, so try numbers. Right, so what's the problem here? You have these, and okay, yeah. At this point, yeah, which we actually don't want to return anything. We want to return null. Or yeah, empty string. Actually, break is correct, but why do I have this problem? Expected by. Okay. If I have got. Oh, alright. Right. So in the end, if yeah, okay. If the current end of word, we do this. else return. No, I think they should work. Okay. Yeah, right. Right, that was actually nice. That was actually a nice one, but let's see if it works. Right, I have some problem. Okay, photos. I check. Yeah, weapons. Ta-da. Oh, do we get the shortest one? Shortest length. Oh, okay. Then it means that if that's the case, or um, or C in current children and C current and of word. Okay, now let's try this. And maybe also this. Right, yeah. So I have one more condition where if I just hit the smallest possible root, just quit there. Alright, so this is with runtime, but I'm using a lot of memory. I guess I'm not sure how to get rid of that, but alright. So that's my answer. What's the time space complexity here? So in tries we have word times length space complexity. So this will be here. So this will be time word and space also the same. WL. And then we go over these words. So that's something different. So we have the sentence words times. So what's the time complexity of this? So longest length here is defined. So it's L. If you can actually yeah, it should be this. You just append it here, return it here. The result is always less than the length of S times L. Yeah, space is actually larger here. Actually, it depends. It depends. If this is larger, that's like that. Otherwise, it's this one, because if the sentence is very long, then yeah, it depends on the sentence and also the words. I'm actually curious about space. Okay, let me check it first. Right, I checked some answers and complexities. I guess they are taking this S times L, which is the number of words in sentence times the average length or length of large, longest word in sentence. They're just taking this as offhand. So they're just okay. So here, like this. It's just of n space is of n, where n is equal to the length of the sentence. But I'm not sure about that, because if the dictionary is really large, then but maybe dictionary length is maximum hundreds. Yeah. Right. So yeah, I'm not that sure about this. But I think this is correct, because this is correct for try complexity. It is WL, or number of words, average length. Yeah, looks up an average. Yeah, so that's correct. Yeah, okay, I'm just gonna stop here, because I think I got it right and the logic is correct, but the complexity is a bit different than what people have in the discussion and in the solution, but they're basically the same, because we are using stripe. Alright, so that was it.